Hey, AP Chemsters, this is Mrs. Vanderlei bringing you Chapter 3, Section 11, Blank Wall. So this is a review of writing and balancing chemical equations. You've already had this in first year chemistry class. And for me, balancing chemical equations is always like a puzzle. I love Sudokus. I love the fact that there's always a solution to it. And so is the case with balancing chemical equations. As long as you know that you have to have the same number of atoms on each side, then you're all set. You'll be able to figure this out, okay? We're going to talk about some simple rules a little bit later on, but for right now, let's see what we're saying. Chemical reactions, what are they? Are the result of chemical change where atoms are reorganized into one or new arrangements. They're just reorganized. So bonds are broken, which requires energy, and we'll talk a lot about that later on. And new ones are formed, which will release energy, okay? So chemical reaction transfers elements and compounds into something new, okay? We have some, reactants go to products, so I think you remembered that. We have some symbols for you. Hopefully that works out for you. S is solid, L is liquid, G is gas, AQ is aqueous. What does aqueous means? That it's in a water solution, okay? So that there's water present in that, okay? We're not going to be talking about energy or time. This is going to come later. We're not going to tell you anything right now about how long does it take for this reaction to happen. We're not going to say how much energy does it take to break bonds and how much energy does it take to form new bonds. That will come later on this year, and that will be new for everyone. We don't really talk about that in first year chemistry. So let's keep going here. Our buddy Antoine Lavoisier, very fascinating young man. If you look at the time of his death in 1794, that was in the height of the French Revolution, and he was actually beheaded because he was a tax collector. He used that job as tax collecting to raise money for his scientific endeavors. And so before he was beheaded in the French Revolution, he came up with some really interesting things. And probably his most famous thing was the law of conservation of matter. We still do that today. Matter can neither be created nor destroyed. So all this balance equation stuff is all because of him, okay? So what does this mean? Well, matter is anything that has mass and takes up space, right? So mass must be conserved. Atoms must be conserved, and that right there is the reasoning that we balance equations, so that atoms must be conserved. Because if we look up ahead, what does this say here? When atoms are what? Reorganized, they're rearranged. You're not creating atoms, you're not losing atoms, okay? They're just being rearranged. So let's take a look at the example of combustion of methane. So methane is CH4. We're going to learn later on in section 11 about some organic basics, and methane is the most basic of the organic compounds, CH4. And we combust it, we burn it. We're not heating it, we're not igniting it, we're burning it. So you need oxygen to burn. And if you burn any kind of hydrocarbon, you get water and carbon dioxide. This goes back to what we did in section 3.10. We talked about the combustion of hydrocarbons to get carbon dioxide and water, and we use those values, how much carbon dioxide, how much water did we make in order to go back and figure the empirical formula. So this should not be anything new. But now what we got to do is we need to balance it. We didn't have to worry about balancing before. We're working with mass and just working with the amount of grams every time. But we do need to balance it now. So it says draw this reaction. So I drew my first one right here, CH4. So I have my black sphere as my carbon and my yellows are my hydrogen, just like our model kits, by the way. And oxygen I have is O2. Those are my reds. And I'm going to make, whoopsies, I'm going to make some water. There's my water. It looks like Mickey Mouse, doesn't it? And it really does look like Mickey Mouse. And then carbon dioxide. Notice it's a linear carbon dioxide. We'll do more about that later and show you why these structures are as they are. There we go. So the question is, count the atoms. Does it fulfill the law of conservation? All right. So how many carbons are here? 1. How many hydrogens are here? 4. How many oxygens are right there? 2. So that's how we have on that side. How many carbons? 1. How many hydrogens? 2. How many oxygens? 3. So right now, have we fulfilled the law of conservation of matter? And the answer is no. All right, come here. No, no. Why aren't you moving? No. Okay, here it comes. All right, no, it does not. So what do we need to do? We need to change it. Well, let's take a look. We have one carbon on both sides, so let's not worry too much about that. Look, we have 4 hydrogens here and only 2 hydrogens here. So can I double the amount of hydrogens? The answer is yes. I have to double the amount of waters, don't I? So now how many hydrogens do I have on both sides? 4. How many do I have here? 4. Good. So now what? I have 4 oxygens instead of 3, and I have 2. So what should I do here? I should have another set of oxygens. Now, does each side have the same amount of atoms? I have 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 1, 2, 3, 4 oxygens. So when I balance it, what are my coefficients? I still have 1 methane, so you don't have to put a 1 there. I now have 2 oxygens, right? I have 1 oxygen molecule, 2 oxygen molecules. What else do I have? I have 2 water molecules right here. 1, 2. And now I have still 1 carbon dioxide. So now my equation is balanced. So how can I do this without drawing pictures every time, okay, to look at it? So here are Mrs. Vanderwalle's helpful hints for balancing chemical reactions, okay? Number 1, use pencil. Why? Because you're probably going to have to erase. If not, you'll be crossing things out, which is all right, but maybe it's a little bit neater if you use pencil. All right, number 2, this is a biggie. Save the reactants or products that are as elements, that are listed as elements for last. So if I'm looking back up here, I would have balanced the O2 last because it's my elemental, in a sense, my elemental reactant in this, okay? Save the elements in a compound that shows up more than twice. In other words, that shows up more than once per side for last, okay? So what would that work over here? I see oxygen once here. I see oxygen twice here. So I would save oxygen for last yet again, okay? Well, I already was going to save it last because it's an element too. And then you go, balance as you go left to right. If you get stuck, double the most complicated looking thing, and keep in mind, as long as the formulas are written correctly, there will be a solution. Keep trying. And that's why I love doing this stuff. It's a puzzle. It works, all right? It's not too bad because there will always be a solution, okay? So keep that in mind. All right, let's go to the next page. So if I were looking at letter A, what are my rules? Do you have a pencil out yet? All right. Do you have any elements written just as elements? In this case, in letter A, you have 2 of them. You have lithium written as an element here and sodium written as an element here. So save those for last. So then what's left? The P's and the O's. All right, let's balance those. So going to go left to right. So my first element, as I go left to right, I see is a phosphorus. I have 1 phosphorus here. I'm going to look over here, I have 1 phosphorus here. Notice there's no parentheses, so I'm not going to use that distributive idea to change the number of my phosphoruses. All right, so that didn't really help a whole lot. All right, so now let's do lithium. How many lithiums do I have here? I have 1. How many do I have here? I have 3. So what should I put in front of the lithium? Go away. I should put a 3 in front of the lithium. All right. Did I change anything by putting a 3 here? Not at all. All right, how many sodiums are here? I have 3. How many do I have here? I have 1. So what should I put in front of the sodium? I should put another 3. Okay. How about letter B? Well, if you look closely, both magnesium and oxygen are written as elements. So I'm not going to save those for last because that'd be kind of dumb. All right. So let's just go left to right. I have 1 magnesium, 1 magnesium. I have 2 oxygens. I have 1 oxygen. So what should I put out in front? I should put a 2 out in front. Okay. Now, what did I change by doing that? I now have how many magnesiums to distribute? I have 2. So what should I put in front of magnesium? 2. And I guess I should go back and check to make sure I'm good. I have 2 magnesiums, 2 magnesiums, 2 oxygens. Distribute 2 oxygens. Okay. What about letter C? This is the combustion of sucrose. Kind of interesting thing going on here. So what should I save for last? Folks, when you're doing any combustion, save your oxygens for last, okay? That would be the best. So I have 12 carbons, 1 carbon. Oh, what should I put in front of the carbon dioxide? I should put a 12 here, shouldn't I? I have 22 hydrogens. I have 2 hydrogens. So what times 2 is 22? 11. All right. So now count up all your oxygens. I have 24 here and 11. So I have 35 oxygens. Well, how many do I have over here? I have 11. So what's 35 minus 11 is 24. So I need 24 oxygens here, and that's another 12. Okay, so go back and make sure that you understand what I just did. I have 12 carbons, 22 hydrogens, 22 hydrogens distribute. I have 11 oxygens plus 24 makes 35. I have 24 oxygens plus 11 distribute, and that makes 25. Good. Now notice in letter D, I see parentheses. So if I put any kind of coefficients in front of the calcium hydroxide or the calcium phosphate, I will have to distribute through those parentheses. So let's just kind of keep that in mind. So in letter D, do I have anything written as an element? The answer is no. Okay, so it says save anything that shows up more than twice or one per side for last. So let's take a look. Calcium occurs only once. How many times do I see oxygen? See 1, 2, 3, 4. Oh, definitely save that for last. How many times do I see hydrogen? 1, 2, 3. I'm going to save that for second last. So what does that mean? I'll do calcium first, and then I'll do phosphorus. Okay, so I have 1 calcium. I have 3 calcium, so what goes out in front? Hopefully you got a 3. Now look at my phosphoruses. I'm going to skip my O's and my H's, all right, because they occur a lot of times. So here is 1 phosphorus. Oh, look. How many phosphorus distribute within the parentheses? I have 2 phosphoruses there, so I'm going to put a 2 here. Now let's do my hydrogens next. Why? Because that shows up 3 times. Oxygen shows up 4 times. So let's count up how many hydrogens I have. I have 6. I have 6. So 6 plus 6 is 12. Here I have 2, so I'm going to put a 6 in front. And then I should count up my oxygen. So I have 3 times 2 is 6. 2 times 4 is 8. So I have 14 oxygens on this side. I have 6 plus, well, there's 8 here. Remember, you distribute, which is 14. Everything is balanced, okay? Letter E, oh, man, I wasn't very nice to you. You have to write out the formulas first, don't you? So why don't you read this and write the reaction? Now, if it's ignited, it is not being burned, okay? So make sure you know if it's ignited, it is not being burned. It's just helping to decompose it, okay? So don't put O2 in the equation. Go ahead and finish writing this, and then make sure that your equation is correct before we balance it, okay? So pause this and do it. Okay, how'd you do? Let's find out. So this is what I got. I got ammonium dichromate. Notice ammonium is a charge of +1, dichromate is a charge of 2 negative. And there's my chromium 3 oxide, my nitrogen gas, and my water vapor. If I was doing it even better, I'd put little S here, G here, and G here. I should have done that. If they give you the information, it's always a good thing to do, but I didn't do it, sorry. So now let's balance it. Why don't you pause this and you balance it and come back. Okay, so is there something that you should save to the end? I'd save oxygens to the end because that shows up once, twice, 3 times. All right, so let's do chromiums. I have 2 chromiums. I'm sorry, let's do nitrogen first. My mistake. 2 nitrogens, 2 nitrogens. What's this? There's 8 hydrogens. There's only 2 hydrogens. So what should I put there? I'm going to put a 4 here. Now I have 8 hydrogens. I have 2 chromiums. 2 chromiums, I have 7 oxygens, I have 3 plus 4 makes 7 oxygens. It's balanced. So I'm going to stop here, and as you can see, what's our next section? It'll be organic compounds. So I'll stop here, and don't wait to be great. See you next time. Bye.